Hello dear students, in this video which is a part 4 of the microbial control topic, I have tried to describe or discuss about one of the antimicrobial agent, that is alcohol, which is popularly used as an antimicrobial agent in routine practices. I have made this PPT presentation video to brief about which are the points required to be discussed while discussing any antimicrobial agent, whether it is physical agent or whether it is a chemical agent, which is required to be discussed while explaining any such agent with respect to your appearance at the exam, or maybe will help you to better understand the various antimicrobial agents in this list. So, alcohol, the huge range of the alcohol are known to us, starting from methanol, ethanol, propanol and the isopropanol, butanol, hexanol, etc. But among the huge list of the available alcohol, we are able to popularly come across two alcohols which are reported to be used as antimicrobial agents in day-to-day practice, and they are ethanol in the range of concentration range of 70 to 90% and isopropyl alcohol, which is used in the concentration range of 40 to 80%. We can understand from this description that isopropyl alcohol is utilizable in less concentration range than the ethanol. We also knows that 70% alcohol or ethanol is commonly used as a spirit or the skin disinfectant. They are bactericidal and fungicidal. Both the alcohols are bactericidal and fungicidal but are not sporicidal. They are also able to destroy some of the lipid containing viruses, that is enveloped viruses. Their bactericidal property increases with carbon chain length, and that is what can be understood well from here, that ethanol is required to be used in a concentration which is ranging from 70 to 90%, whereas isopropyl alcohol can be used in the less concentration range, that is 40 to 80%. So, it says that bactericidal property of the alcohol increases with chain length. However, as the chain length increases, the solubility decreases, and so that the carbon chain length of more than 3, that is butanol onwards, are not commonly used as a antimicrobial agents because of their lack of miscibility with the water. They are not able to mix properly with water, which is a very essential requirement for antimicrobial agent, as we have seen in the last video. Against to that, methanol, which is able to be solubilized in water in all the proportion, is not popularly used because of its poisonous nature for the animals and human beings. It is highly poisonous and irritant to the mucous membrane and can cause permanent injury to the eyes, and so it is not popularly used as a common antiseptic. In addition to their sole effect as an antimicrobial agent, alcohol, when added to the other chemical agents, is reported to improve their effectiveness. Like alcohols are the one of the important ingredient of your day-to-day used antiseptic, there is Dettol, Lysol, and even it is a good mixed content or the component of the tincture of iodine. Now, if we talk about the mode of action, alcohol are reported to be able to denature proteins. They are protein denaturant. At the same time, they are acting as a lipid solvent. That means they are able to denature the proteins which can be playing structural role, which can be playing enzymatic role. At the same time, if they are lipid solvent, they can be able to affect the cell membrane integrity, as we have seen the second part, or the second part of the video of this group of videos I have made for this topic of microbial control. So it is helping to prevent it will help to damage the cell by affecting the proteins as well as lipidaceous membrane. It is able to show cleansing property because of its low surface tension action. So what is the concentration which is found to be effective? It is for the ethanol observed that greater than 50% concentration is effective as a lipid solvent, help to disintegrate the cell membrane. At concentration greater than 50 and up to 90%, they can be able to denature protein. So higher concentration will be required when it is going to act as a protein denaturant. However, when it is used absolute alcohol form, that is 100% alcohol, it is having dehydrating effect on the cell wall, and that means it is not able to penetrate now inside the cell to cause any damage to the cytoplasmic protein, and it's just merely remain as a inhibiting agent rather than destroying agent. Coming to the advantages, what are the advantages of the using the alcohol? It is less toxic, and so it is popularly used as a skin disinfectant. Limitations, as you have seen that the effectiveness of the alcohol series increases with the chain length, but increasing chain length reduces its solubility. So this is one of the biggest limitation with the alcohol group of agents. We have also seen that dehydration effect created by the absolute alcohol prevent the entry of the alcohol itself in the cytoplasmic area to cause further damage to the enzymes and the other proteins in the cytoplasm. That means it is in itself is acting as a inhibitory agent, not as a killing agent. So here it just remained as a bacteriostatic agent rather than bactericidal. And in addition to that, whatever the concentration we are using, mostly it is reported to act as a inhibitory agent rather than killing agent. So it is not a sterilant because it is not able to destroy the endospores. We cannot say it to be a sterilant. Additionally, extraneous protein material, organic substances are quickly reacting with the alcohol, and they are thus reducing the effectiveness of the alcohol. Coming to the practical application, as we know that it is widely used as a skin antiseptic or disinfectant, and we are using it most popularly for vein puncture. Before collecting the blood for clinical analysis, the skin area is disinfected by the spirit, right? So for the venipuncture or for the capillary puncture, this is most popularly used. And even while giving the injections or during vaccination, the skin area is degerminated, it is undergoing degerming process with the help of alcohol, and that is spirit, either ethanol or the isopropyl alcohol. Additionally, it can be useful to cause instant disinfection of the fragile or delicate instruments like thermometer and surgical instruments. So this is how any antimicrobial agent can be discussed under the headings of what is the mode of action of that agent, what are the advantages of that agent, what we can enlist as a limitation and for which we need to go for other alternative to be relied upon. Then what are the practical application of any antimicrobial agent should also be discussed while discussing any a list of physical and chemical agents used for microbial control. These are the references. Thank you.